Hey everybody, this is Larry. This is me going over uh, day 21 of the Leetcode, or day 22 of the Leetcode Daily Challenge, some of the distances in tree. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. So this was a very long video, so I'm doing the explanation near the front. Instead, you could watch me solve it live during the quote-unquote live recording, but that's what I'm trying to do here. One thing that I would say, so I got very frustrating about this, so I got a wrong answer. But so that I was just sending links to people to use this one, and this is something that I do a lot. But in terms of tree problems, this is something that I do a lot. But there is actually a really bad case that is n squared, which is not in the inputs, but it can kind of get messy, and this is why I kind of spend another 40 minutes this time to actually get it right. So even though I had a video out, I think that's a wrong answer. And why is that, right? And sorry if you're looking for I mean, I'll go over the details in a little bit, but I just want to point out this case because and I talk about this a little bit, which is that the naive dynamic programming on the edges is what I would do for this problem. But the problem is that, so what do I mean by that, right? So let's say you have a tree, you know, and then you have some answer, right? And then basically for every directional thing, you just kind of be like, hey, what is the distance of, what is the total distance of here, right? Well, here, this arrow is cached, so then you can kind of go back up, right? And in theory, this is fine and stuff like that. And you get reused because let's say you're trying to process this node, and it goes this way, and then now it goes to this arrow again, and then you reuse these things, right? So that's a thing that I always try to do. But the problem is that if you're not careful, and I haven't been in the past, and I've definitely failed a lot of things previously, so that's why I'm really careful about this time, and I wish that I did a better job explaining this when I did it live, that I have to add an addendum to it because it is a very hard problem, I think, to do in optimal time. It's very easy to mess this up in optimal time, and I in my previous solve of this, I believe I kind of messed that up as well. But this time I solved it correctly, which is why it took me like 40 minutes. But it's a lot of bookkeeping and a lot of math, but yeah. But basically, the biggest issue is if you have a tree that is a star graph, right? So something that looks like this. The problem with how we did the recursion with memorization is that it still takes you still have to go through the edges every time you even if it's cached. I think that's the problem, right? So basically, for example, what I mean here is that let's say let me try to use a different color. Let's say we start at this node first, and then of course we do recursion, we go here, and then now this node, we go, okay, yay, we have all these things, right? And we have all these out edges cached. Okay, and then now we have the answer, right? The problem is that, okay, let's say you have your second node that you process, and you process this one. Now, obviously, you don't have to cache here, but then now, because you went this way, now you're here. Now, of course, all the outgoing edges, and maybe you cache this, and it's fine, right? All the outgoing edges are memorized, or stored dynamic programmingly. So yeah, so everything is memorized. However, even if they're memorized, it takes O of n times to just loop for the edges that time, right? So again, now let's say you tried here, and then now it O of n, and in that way, it degenerates to n squared. And I believe that, and this is something that I've done a lot. I talk about this in the original live portion as well, is that I always forget about this case. It messes me up a lot. So this time I'll try to be very deliberate about it. And the constraint about this problem is that 3 times 10 to the 4th, which maybe the worst edge case isn't in here, or at least it's not in here enough. But that is an issue, right? For that. So yeah, so the way that I did it, however, is just by, actually let me bring this back up again. The way that I did it is just by doing 2 depth first search. again, it's basically keeping track of. I don't know if this is the best graph for it, but maybe not. All right, let me just draw another one. A second. But yeah, let's just say without loss of generality, you can root the tree in any node or whatever, right? And basically, for every node, what I try to do is to keep track of the total sum, or two numbers, total vertex. So let's just say we call this V, and total number of edges or number of distances. The sum of all the edges and all the sum of the distances on this one. And then then the answer from that is that, okay, now let me choose another color. Now we do it from the top, right? And then we recurse this way, say. Doesn't really matter, right? And there's some other, okay, so V of 1, oops. So now we have some V of 1 and Y of 1, or maybe V of 0, say. I mean, And then this one, there's V of 1, Y of 1, right? So basically, after the first recursion, it's just a matter of keeping track of everything. And if you watch me do it live, I had a lot of off by ones. But basically, you do one pass, get all the V's and E's, and then now on a recursion, you can figure out all the maths here by just a lot of bookkeeping, which is kind of tricky, but with enough time, and you see me struggle with enough time, you could get it right. Because basically, well, for example, let's just calculate this delta H, right? Handwriting is terrible, that's why I type. This delta H, so basically, V of 0 contains, at a basic level, let's just call this V of 2, right? And of course, I drew a binary tree, but you can have more edges. But basically, V sub 0 is equal to, V plus 1 plus V plus 2 plus ... right? And E sub 0 as well, right? So now, what is the delta here, right? Well, from the perspective of the V1, right? Well, that's just equal to V sub 0 minus maybe not V1, but let's just say we want to pass in the total if we were to root it at V1, right? So that means that, well, V sub 0 minus V1 contains all the edges, all the nodes that are on the left side, right? Like going up, right? Because V sub 0 will contain V sub 1 plus V sub 2 ... So let's just say V sub 2, but in theory, there are more edges, so like it's equal to V plus 2 plus V plus 3 plus ... right? So that's the other side, right? Yeah. And then edges, you do a similar idea, but a little bit trickier to get right, which I took a long time to get right? So basically, the other sum is going to be equal to just also E of 2 plus E of 3 plus ... But then now, how do we incorporate that, right? Well, now E sub 1 is equal to, let's just say E sub 0 minus all this other stuff. E sub, let's just call it E sub total, right? To get the edges that are over there. But each of them actually moved one step closer because it moved that one distance. So then it's subtracted by this thing plus V sub total or something like that, right? Because now all those paths, is this is minus. No, it's plus. Whoops. Because now all of them are one more distances away, right? And we want to subtract that, I think. I think that's right. I think I'm confusing myself again. But in any case, that's basically the idea of that. You just have to keep track of everything along the way. I think I might have an off by one Maybe my signs are wrong on that one. But that's basically the idea about the code. And hopefully you're able to implement it from the idea, because the code is a little bit yucky for that. I should have labeled things a little bit better. But here we kind of do what I said with respect to the just calculating the detail depth of search to calculate all the sum of edges and all the sum of the edges and all the sum of the vertices. And then here we use that, we use it to calculate the answer, and then we use it to kind of calculate v other and ye other as they move from farther and farther away. So that's basically the idea, because we add the ye other, and because for each of the v other they're one step away, but and also all the v's are one step closer, one step farther, I suppose. But then we have to minus all the children stuff that is closer, right? So that's basically the idea. Yeah, that's all I have for this one. Sorry if the video is a little bit bad, but it's a very tough problem. What is the complexity here, right? The complexity is actually v plus e, because we just do 2 depth first search with a lot of bookkeeping and math, but it's v plus e, which makes this linear. And that's pretty much it. It's very easy to get the amortized stuff wrong, and that's why and I made this mistake a lot in the past. I'm not even joking about it, and Josh would always be like, oh yeah, you forgot this case. I'm like, oh yeah, this again, right? Like, it's not the first time. So yeah, so definitely be careful. And that's all I have for today. You could watch the live recording of this, of me solving it, coming up now. Hey everybody, this is Larry. This is day 22 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 834, sum of distances in trees, and it's a hard problem. We've been doing a lot of graph problems and tree problems, so we'll see what today's difficulty is. And of course, if you have premium, oops, that's not what I meant to do. But I mean, there's a weekly premium, which I hope to do afterwards. So definitely stay tuned, hit the subscribe button, all that good stuff. Even if you don't have premium, you could watch me, look into a problem or whatever. Anyway, so 834, sum of distances in tree. Okay, so there's an undirected graph, undirected tree. Connect the tree from 0 to n-1 and n-1 edges. That's standard. Okay. Return it. You're given an integer n and an array of edges. Okay, so you have edges. Okay, you return an array n's of length n, where n supplies the sum of the distances between ith node and in the tree and all the other nodes. Okay. So basically, let's see. So, okay. Let's think about this for a second, because I feel like every time I've done this, I do, I'm not gonna lie, yeah, every time I've done this, I do some kind of dynamic programming, which works, well, or actually, what if it works, then I would have just done it. But what happens is that every time I see this thing, and I've been making this mistake a few times, so I'm trying to learn as well, so perhaps today we'll learn together. But it's that I do this thing where let me take a look at n. Okay, n is 3 times 10 to the 4th, so you can't do anything n squared is what I was going to say, because, well, if it's n squared, it's easy. You just brute force everything from everything that we've been doing with the shortest path from each one. But what I was going to say is that yeah, I always had this dynamic programming problem on the edge, but I always and I always make this mistake. So today I'm trying to be a little bit better. Is that the problem that it fails for is this a star graph where it goes in and then it still calculates all the other ones, even though it's cache, and it ends up being n squared, even for a tree. So trying to do a little bit better about it. How do I do it, right? So the thing to, I mean, I don't know off my head, even though apparently I've solved this before, but I actually don't. This is like one of my weaker points. So hopefully y'all, will be here and we'll do this journey together. the observation that I would make here for now is that you don't need to know the answer, or you don't need to know the paths. All you need to know is the sum of the paths, right? Sum of the distances. So maybe in that way it is a little bit different, and maybe in that way we can maybe dynamic program on that, but that's an observation. And also, if you're tuning in now, or if you're still here, I am doing this live, and usually I hope that you don't get spoiled by the fact that I know enough that usually I'm already explaining the problem and the solution. But right now I am actually solving this live and trying to make sure that, we do okay here. Okay, let me think a little bit. I think for now I just have to figure out the proof of, okay. Because then the idea, okay, so let's say we do a depth first search on node 0, right? And you could depth first search really on any node. There's no, it's just without loss of generality, and we get the answer there. So that's trivial. You do a depth first search, it's a tree, so you get the shortest path. I mean, depth first search is the shortest path because there's no other way. And well, I mean, at least without repeated edges or something shenanigan-y. Okay, so now let's say we calculate and we got 8, right? How do we get the answer for the other parts, right? Well, and once again, I want to do this in a smart way, so that I want to do this in a smart way so that we don't run into that star problem. I'm trying to think whether we could still do one depth first search and then be like, okay, these are the answers to the left, these are the answers to the right, let's combine them, but also pass the answer to the other side, to the other side or something like that. And I don't know that doesn't grow exponentially. That's what I'm trying to think whether that does. Yeah, okay, so all these cases are just like, hey, here's some edge cases. Okay, just want to double check the constraints, but it seems okay. I am stalling right now for time, to be honest. By just kind of typing out code that I already know what to do, which is converting the edge list to an adjacency list. This part, I should be able to do pretty quickly. And I'm done. Okay, so let's say we do recursion. Okay, and now we go, and now we have to go back. Is that third week? Or we could just do 2 recursions. Maybe that's the better way. Because then now we just take all the other ones and then yeah, okay, let's give that a try. I think maybe I'm yeah, I think we just start with a regular traversal. I got depth first, but you could do it in any node. So this is the current node, and then for we in adjacency list of node, we traverse to we with node being the parent, and this is a tree, so we just make sure we don't go back to tree, right? Okay, so that's really the entire traversal. What we want to do is make this return stuff. We want to return the number of nodes and the number of edges that we've seen, meaning the sum of all the paths, kind of. Okay, so yeah, so nodes is either equal to 0. Edges is equal. I don't want to shadow this, so let's just say. Okay, fine. Let's just say v is equal to y is equal to 0, right? And then maybe recurrent e current is equal to this thing, and then we just sum it, right? Well, sum it for the vertex, it makes sense to sum it. Edges, what does it mean, right? Well, now each of those paths have one more distant array. So I have to double check my math here, but it's basically this plus VC, right? Because that's the number of nodes, and all those nodes are one path away. Maybe I have to do a +1, but I think that's roughly maybe right. And then here, we just return v plus 1 and y. V plus 1 being the current node, and then the distance, right? Okay. Yeah, okay. I'm sorry, I'm like thinking through it a little bit. Of course, we should yeah, we should store this. Let's just say I don't know. Naming is hard, but let's just call it whatever, right? And then here we want to cache that details of node is equal to this thing. And basically what we're saying is that what we're saying here, what we're returning is the sum or the number of nodes rooted here, rooted on node with the without going up the parent, and also edges, right? Something like that. Okay, so then now we can use it in theory, right? So let's just set this up times n. Don't know where the parents came in, but the type clicking the wrong things. And then we return answer, of course, but then before that we want to do maybe a second traversal, and I don't have a creative name. Right, and then basically now this time we want to, and actually there may be more. I have to think about how to do this in a good way, because now you're accumulating the other way with knowing that the path that you're missing. So maybe there's some like v and y here as well, but I have to be a little bit careful here. Yeah, like I said, maybe there's a lot of off by ones, but I think that's a good idea, a good enough idea anyway. Okay, so basically now we have for v an adjacency list node, right? Basically, okay, so we let's just call this v other and y other, and then now, or from parent, maybe you want to say it that way. And then now you could say v y is equal to details of node, because we calculated this before. Also, I just noticed that we kind of messed up by we, because Larry messed up. It's a we when Larry messed up, but clearly this is used here. Let's just say child, fine. This was also an issue that I had yesterday on Advent of Code. I just kind of shadowed variables, silly mistakes. It's kind of sad. Okay, so here, yeah, because presumably parent have already done it. So yeah, okay. So basically, this gives you the number of nodes that are rooted here. So now you just have to add in the stuff from the parent, right? Yeah. and from the parent is this thing. Yeah. So okay, but let's. I mean, I like to kind of break it down step by step, and so now I'm still thinking of the root node first. Yeah. So okay. So basically, what I want to do here is, what am I doing? We're not doing the recursion yet. I mean, we have to do recursion so that we process it for every node, but we don't have to return anything in a recursive way. What we're doing here is basically getting details of this child, right? Yeah, let's just say recurrent is equal to details of this child. Actually, I'm going to run it real quick just to make sure that I don't have any other typos. Or like, you know, it should just give me a wrong answer with this thing, which I expect actually. So that's good. I was just, if I had any other errors, then it would have came up hopefully. So so I was just double checking for that. Okay. So then now we have the details from this child, and it's like some maths here, right? Wait, do we care about this? I think, okay. I think maybe I just confused myself a little bit. Okay, actually, I don't think we, because I think I was trying to process the child, but we don't need to process the child. What we need to do is just answer of node is equal to v plus v other, right? Now coming one pair. Maybe I'm off by one, but I think that's all I need. And then now we don't need to do whatever this craziness that I'm doing. What we now is just traverse two of we want to go child, the current node is the parent, and then now we have v other plus 1, because now everything is one step closer, and then ye other. Now I need to do some other things here, because basically you want to also aggregate all the other stuff on this rooted here. Like for example here, if I need to aggregate all the other stuff, but that's a function of v, right? So basically, this is so hard. Basically, okay, so I guess I had some ideas and that was kind of right. I think I just kind of confused myself. This is very hard for me, so I don't know. If you do it better, let me know in the comments. Then you know. But basically, okay, so that's the child, and of course, v is the sum of all these children. So then now v minus vc and e minus ec is the other child, or all the other children, not including the ones from this detail stuff. And again, there may be some off by one stuff here. And then now is plus v of other, because now you're counting the one coming from above. So something like this. Again, I'm way prone to being off by one, but I think that's generally what I want to express, at least an idea. So let's give it a spin. Okay, well, I was half hoping, but not that surprised. That looks very wrong though. I should at least get the 0, right? Like, why is it giving me 6? 0, 1, 2, 3, 1. So 2, 3, 4. I don't also, maybe I calculate the distance wrong. So of 1 is 1, 2, and then 3. Okay, no, that's right. Okay, so I think the first thing to do is just print out details. Maybe I could have done a little bit better debugging it by pieces, because I'm really not confident here. But okay, so 1 is 1 0, that's good. 3 is 1 0, 4 is 1 0, 5 is 1 0, 2 is 4 3. So including itself has 4 nodes and has 3 total distance downward. So that's good. 0 is 6 8. Did I just return the wrong thing? Is that why? Oh yeah, I did. Oops. Okay, so at least I got one thing right now. That's progress, friends. Okay. And this detail stuff still is correct, but now we have to kind of do some math. So what? We put in node v other e other, and maybe we see something like that. I feel like maybe I'm just double counting something, or in this case undercounting something because our numbers are smaller. So yeah. Oh, oops. What does it see? Okay, so 0 have 6 and 8, 1 1 0. Okay, and other is 5 and 8. What does that mean? So that means that up at top, that's 5 and an 8. So then that means that we did not. I think this we have to do the same thing here, kind of, in that our ye other has to plus we see or something like that, or no, plus we other, yeah, because ye others and plus we others, it may be off by 1 still or something like this, but okay, still a little bit wrong, and a lot wrong actually. Okay, so this is 5 8, and the 8 may just be wrong, but yeah, but this idea is just the same as here, in that each of the ye other node or we other nodes got ye other nodes, but it may be off by 1. So now this is overcounting for 2, so we have to figure it out. So it's not unidirectionally wrong anymore. Okay, at least these things are right, which is good. Okay, so 1 we have 5 and 8, right? And the answer is, so is 8 right? So from 0, let me think about this. This is tricky to kind of get right precisely. Okay, so 0 has 6 and 8. Okay, and that means that if we go to 1, of course, there are only 5 nodes to the right, which is reasonable. But the path is 8, which may not be as right. Because basically 0, well, 1 is that we have to subtract 1. So I think I have to add a subtract 1 somewhere because we ran down that path. So definitely that's the total distance. The nodes don't ever change for stuff like this. Now the other stuff is wrong. But maybe I miss. Let me rethink this. Okay, but I feel like we do though. I'm just doing it a little bit weirdly, because that's why this thing is overcounting. But okay, so basically we have to subtract 1, but then we have 5 nodes. So so this one has 0 edges. What? Did I messed up somewhere? Oh no, this is on the parent. So on the parent we have 6 and we have 8, right? So basically we want to pass in we want to pass in 12. So I feel like, okay, so there's 8. So basically this is 1 and 0. So this is 6 8 0 0. Okay, fine. Oh, I think this we also need plus v. Oops. And then maybe -1 for getting closer on that one. I forgot that each of these vertices that are already existing, basically they're all on the other child, but now they got closer. So yeah. Okay, so I'm still off by something. Okay, so then here we have 6 and 8. Oh, because we do the recursion, there's 5. I think that's, yeah, I mean, because we see is 1 and 0, so now there's 5, and then each of the 5 nodes got 1 farther, so that's 13. Oh, I feel like I'm close, but I'm double checking my head. Well, maybe not. I don't know. At least I have to. But okay, how do you get 13? Because it's 8 plus 5. Well, it's okay. So basically, it is saying that for this one, this is 1 and 0. So we have 6 and 8. So that means that we have 5 and 8 on the other thing, right? The node should be fine. I mean, it goes to 5, and it is true. The edges are not so much. Basically, we have 8 of them. We added back to 5. These things are 0, so they don't do anything. Minus the EC, so yeah. 6 plus. Did I do that wrong though? 5. So we have. Is the sum of edges wrong? Basically, I think 8 is wrong because it includes the 1, but I think I factored that in by subtracting by 1. I think that's wrong actually. No, I think that's fine maybe, because I was thinking about because I think I have to also minus VC somewhere here, because all of them are one closer. But yeah, I think maybe that's why. Okay. Somehow, oh, well, these are silly cases, so it doesn't, I was like, huh, that's good. Okay. I'm not very confident right now, but this makes sense, I think. Okay. So then, how do I get a 9 on 0, 1, 2, 2? Okay. So 2, we have 2 and 6 recursively. And this is just very annoying debugging, sorry friends. Okay. I wonder how I did it last time, I'm curious, but okay. What am I doing with 2 and okay, so I have 6 and 8, right? We go down this way, we go down 1. The other side of the path has let me think. Okay, so 2 is 4 and 3, right? So that means that there's 2 nodes on the other side and 6 edges on the other side, which is really wrong, I think. So basically, this has to be, but then we minus the VC. So basically we have 8. Let me try again. Okay, so we have 6 nodes, 8, and we have 2 on the other side, and a total of, in theory, just 1. Something is, why is this 6? So 8 minus 4, 8 minus 3, it should be 3 plus this, right? So it should be minus 7 at least, because there are 4 nodes and all of them got 1 closer. But I think that's what I have by having it here, right? This is such a ridiculous formula. So basically, I have 8 plus V. Now the V part is a little bit awkward, but maybe not. I mean, this gets, because what it's saying is that all 6 of them are closer, but it is minus VC. So I think that's fine maybe, because only 2 of them are closer. And then the EC is this 3 from here, so that means that is EC. Is there an other minus EC? That's why. Maybe that's why this is so. Okay, wow. Because I think my confusion was just that, like, having to do it twice. because I kind of came at it at a very weird angle. And I'm sorry if this was very hard to follow because I am just thinking about it for myself. But basically, okay, I hope to. Well, let me just submit it first, and then if it works, then I'll explain it because otherwise it's just embarrassing. Oh no. Okay. So I still have something wrong with my maths. Let's do it here. But yeah, the making sure that I counted right was kind of tricky. Also, I still have some print statements, so that was kind of bad. But is there like a drawing thing? No, they don't have. All right. Let me find a pencil so I can draw it. I need to draw it. My finger. My pencil. I used to have a lot of these. I think my current table setup is just messy. Okay, fine. Alright. So basically, on this one, it is 0 to 3, 3 to 2, 2 to 1. So it is basically a linear thing, a linked list. Okay, so of course it should be 6644, I suppose. So 6 we have, so 1 we have 1 0. Okay, fine. 2 we have 2 1. Fine. 3 we have 3 3. Fine. And 0 we have 4 6. Okay. Okay. So basically, if we're this is so tiring. Basically, going back, there's 3 5 coming in. So it should. Why is it only 5 coming in, not 6? Because we should have added all the other ones. Yeah. Okay. Well, I guess some other stuff is off by 1 as well. So okay. So let's say we have 4 6. 3 on the thing, 1 on the other. This should be 1. I think that's where this messed up. This should be 1 because. No, should it? This should be 1 for the node that just passed by. I think. Maybe I'm just confusing myself, to be honest. Did that solve that one? No? Okay. But basically, it is saying that the other should contain 1 because literally I need to take this out in a good way. Okay, fine. If I was a smart man, I would put this into multiple variables, but now I'm too far into the confusion that is a little bit tricky. So okay, so let's say we have 4 6, we go 1 deep, and this should be a 1, just and that means that some other stuff as well. Right. This should be a 1 just because. Okay, so VC is 3 3. Okay, so we have this. We have 4 6 recursion into 3 3, which is true. It means that on the other side there's 1 node, of course, and then there's 1 edge, which is the thing. But instead, I have 0. So the reason why this would have 1 other would be, so we have 6 edges. I'm just writing on my notebook, sorry friends, you can't see it. I'm just really not doing well on this problem right now. But okay, so we have 3 minus the children of, oh no, let's go back first. I'm confusing myself. Okay, so we have 6. We go back, we say the child has 3, okay, and then we minus 3 again. No, I think that's why. This should be a VC. Maybe not. I think maybe. But maybe. Okay. Now I don't remember why I had these anymore, so it's very confusing. Okay, so, but basically we start with 6 edges going down, and then we have 3 on the child. We have 3 nodes on the child as well, so each of those are 1 closer, so that means that it is minus EC minus, so 6, wait, so I'm just struggling hard. Okay, so 6, so we moved 3 of them from the, what am I doing? Okay, so there's 3. Now we're just looking up the other stuff, and there's 1 node, and then it should be return 1 1, but what it thinks it's doing is, I don't remember my logic anymore. So the 6 minus the children of that. No, wait, no. Yeah, so it minus the children of it, and then it minus it again. Okay, let's start over a little bit. Okay, so the child should have E plus E other, and E other plus V other, right? And that's just the stuff coming in, because all of these edges, or V of these edges are, you know, and then the minus 1 may be the part that doesn't make sense. Why do we minus 1 again? Oh, because of that edge, but it's not that. I think that's the part that's the confusion, because we have to minus something else, but the minus 1 was just for the edge that is for that, but for that node, but that should be factored into all the V other maybe. I am just struggling on this one, but this one, it got this number right, just somehow has 8 instead. Okay, so this is passing into correct recursion at least, so maybe I just messed up some other stuff, which is fine. Oh, so it did get this one. Okay, so the 1 1 recursion is right for the stuff that comes in. Is the 2 4 right? Now it should be 2 3. Oops. It should be 2 3 just by symmetry, right? Because it was 2 3 on here. Should it? Let's see. So basically on the number 2, we have, yeah, 2 nodes and 3 on the other side. So 2 4 is definitely wrong. Why is it giving me 2 4? Is it because I had this now? I think I just got, okay. I think because the second time I said EC, it should be VC. It doesn't make sense that we minus the edge twice. But I don't know. I feel like I'm not doing a good job here of explaining or even solving. So okay, let's give it some mid real quick, and then okay, huh? That was a very tough one. It's doing linear time. What did I do last time? I guess that's what I wanted to do, but I clearly did not do it this way. Past Larry is smaller too than current Larry, but that's because I did it in this way. That is, yeah, I guess that's what I did here. The way that I structured this is way smarter though. I think I tried to do too much in my head. Oh no, I think this is okay. I guess time is passing. How do I explain this? I mean, it's just a lot of bookkeeping and making sure that you keep track of everything. I think the idea is actually not that bad, even if I did spend 40 minutes on this, which is embarrassing. Well, not embarrassing, I don't, but it's just, I was close, but I think I just kind of did not explain this, did not really go over this that much. But basically, the new edges is equal to, so e plus e other is the number of edges for this node, right? This current node. Okay. And then now we add plus we other because now all those nodes are one. Like if you go into a child, they're one step further on the edge. So this is just a new edge other, if you want to think about it that way. And that's why we have this. And then yeah. And then basically, I guess that's maybe it. We want to minus all the edges from the, because we don't want to count. We're subtracting EC because now you're going all the child. The child knows that the child already contains all the stuff that's already in EC, right? So it doesn't need to know it. And then we want to minus VC for that reason, because all of those edges that are coming from your child, all of them are actually closer by 1. So that's the number of VC. I don't know. I think I'm making stuff up now. I don't know. Sorry, friends. I think I have this video, so just check out that video. I feel like I think I have the same idea, but I've been doing. I think that's what this formula kind of goes to, but today has just been a really weird day for this problem. So yeah, sorry, friends. I'm having a bad day. So yeah, check out that video. Let me know what you think. Stay good. Stay healthy. To good mental health. Sorry about today. I'll see you later. Stay good, stay healthy, to good mental health. I'll see you later. Take care. Bye bye.